Alright, you guys, this is Chapter 1 review for Geometry AB. We're going to do odds. If you have questions on the evens, please come in and see one of your teachers. That would be great. The first section is asking if the points are collinear. That means that points are on the same line. V, X, Z are all on the same line right here. So that would be a yes. V, W, and Y are not all on the same line. That V is not on the same line as W and Y, so those would be not collinear or non-collinear. The next section is asking about coplanar points. We know coplanar points are points on the same plane. So number 5 says V, X, U, and Z. V, X, U, and Z. And these guys are all on the same plane, and that plane is drawn here for us. So yes, those are coplanar. If we look at V, X, Z, and W, you notice that you have the same points that are on that line right there, and then W is right here. So they're not all on the same plane that's drawn, but they could all be on the same plane if we drew it vertically. And if we drew it vertically, it would intersect this plane at the line, and then it would include point W. So in this case, they are coplanar, so that would be a yes, because they could be coplanar even if it's not drawn. So that's a tricky one. But if you need more clarification on this, then we can do a visual demonstration if you come into tutoring. Let's look at number 9. It says ray XV, so this guy right here, and ray XY are opposite rays. That is true because they have the same endpoint and they go in exactly opposite directions. Number 11 says ZX, so the ray that starts at Z and goes to X, is the same as ray WZ, that one right there. Now in this case, this is false because they're not the same. They have different endpoints and they go in different directions. So I would say different endpoints and different directions. When we look at 13, we're now talking about segments, so pieces of a line. So is the piece from V to Y, that piece of line right there, the same thing as the piece from V to X? And it's actually going to be not true. It's going to be false because this piece right here, he's smaller than the piece from V to Y. So I would say VY is larger. So they can't be the same if VY is larger. The next section is our number line, and I told you guys you could do this a few ways. I'm going to illustrate the number line method. So notice that my number line is missing numbers. So what I want to do before I even get started is just fill in those missing numbers. Now it looks like a complete number line. And when it's asking us to find AC, CD, and DA, it just wants you to find the distance or the length of that piece. So from C to D, I'm going to start at C and I'm going to go to D. 1, 2. That is 2 hops or 2 spaces. So the length of CD is just 2. True or false? So is length of AB the same thing as the length of CD? So we want to refer back to this guy. This number line is the length of CD 2, the same thing as the length of AB 2. I would say that that is true. Number 19 says, if I add AB plus BC, do I get the same length as AD? Well, I know AB is 2. Let's find out what BC is. From B to C, you go 1, 2, 3, 4, 5 hops. So that would be a 5. So 2 plus 5. Let's see if that equals AD. Sorry about the flipping back and forth. From A to D, you start at A and go all the way to D. That's 1, 2, 3, 4, 5, 6, 7, 8, 9 total hops. So does 2 plus 5 equal 9? No, it does not. 2 plus 5 equals 7. The next portion is all about segment addition. So you're taking 2 pieces and adding them to get the total. If you're given the total and 1 piece, then you would subtract. For instance, number 21 says KL is 18, LM is 30, so what is the total? If I'm looking for the total, then I add these 2 together and find the total. So that should be 48. 23 is still going to use that same picture, but I already labeled that picture with a different problem, so I'm just going to redraw KLM and then label the picture again. It says KL is 2x plus 7, LM is x plus 1, and the whole thing is 47. So what we're going to do again is take this piece, add it to this piece, and set it equal to the total. So 2x plus 7 plus x plus 1 equals 47. Then combine your like terms. 2x plus 1x is 3x. 7 plus 1 is 8. And then solve for x like normal. You're going to subtract 8 from both sides. So you get 3x equals 39. Then divide by 3. So x is 13. Similar type of problem to number 25, just a little bit more complicated. You've got K, L, and M. KL is 2x plus 9, LM is 3x plus 4, and K to M is 8x minus 20. Now, just like I was telling all my students, make sure you draw and label your pictures in geometry. When you do that, hopefully you'll see that this piece plus this piece equals the total. So I'm going to add them and set it equal to the total. 8x minus 20. You want to combine those like terms together. 2x plus 3x is 5x. 9 plus 4 is 13. And then we solve just like normal. Subtract 5x from both sides. Get 3x minus 20 equals 13. Add 20 to both sides. So you get 33 equals 3x. And then, oh, I'm sorry, can't see that. Divide by 3. So x equals 11. It asked me for x, but it also asked me for KL. So if you want to find KL, then you go back and you plug in, here's KL, you plug in what you know x was. 2 times 11 is 22. 22 plus 9 is, what, 31? So KL is 31. That's it for pages 1 and 2 of your geometry review. If you have questions, please come in, ask a teacher. Mrs. McKeever, myself, I will be here before and after school on Tuesdays and Thursdays. Thanks, guys.